Hey folks, welcome back to the channel. So we're still working on my little custom Champ build. It's a project that I started one episode ago if you want to go back and see that episode. But we've been working on the chassis so far, and I produced this layout drawing and I've already gone back and modified it just a little bit. I'm going to use a little bit of a different scheme to get the 68K resistors connected from this input jack to the board. I think I'm going to actually move those resistors to the board itself so they're not hanging off the back of the input jack. And I determined that after I was looking at the space that I had left here behind the input jacks and where this board was going to land inside here. So at any rate, we'll cross that bridge when we come to it. But I need to cut this board to the dimensions that are shown in my layout here. And then once this is in place, or at least close to in place, I'll know where to drill for my tubes. So as you can see here in my layout, I've got enough space for the 6X4 to sit between the board and the transformer. I might actually move it a little bit this way. I like the option that I have to have an extra set of holes behind all these capacitors because it's going to allow for a little bit easier hookup with some of these wires. I produced this version a long time ago, then I corrected it with this one here that puts the 68K resistors on the board. Then I produced basically a squished version. So the sizes that I've got as options are basically a short, a long, and a medium version of the same layout. And I'm probably going to go with the medium just so that you're aware. But like I said, I'll produce the full layout at the end of the video series along with the full schematic. As I've mentioned before, I haven't actually used this material before. It's kind of a silicone or PCB based material. It's very rigid and I don't exactly know how to cut it, but I'm going to give it a shot with a utility knife and a square. And I've obviously marked off my cut here. I'm just using the square as a guide, and let's just see how this works. I'm going to score the back side too. Okay, well this is tougher than it looks, but I've got a scored line here and I'm just going to keep working on it with the utility knife until it pops. After some continued scoring with the utility knife, I was able to snap it, and now I've got two nice pieces of board. The longer one is the one I'm using, and this one I can save for a future project. Now what I wanted to check with this was whether or not I could get this in here with enough space to go under the input jacks, because that allows me to move this as far forward as possible and leave room in the back here for those tube sockets. And it looks like it's going to work out just fine. It does depend a little bit on how I mount this board, but I've got a plan for that. I can go ahead and drill for the 6X4 rectifier. I've got a tiny little 7-pin socket here. Looks like it's going to take about a 5/8 hole, so I'm going to go ahead and drill that. I went ahead and measured it. It's going to be right in the center of my chassis, and it's going to be right in the center of the space between the transformer and the board as well. Alright, as we continue plugging along, I've got this hole cleaned up. I did do a little touch-up paint around the edge. Got a couple of sheet metal screws in, holding my socket in place, and everything's ready for that 6X4. Now we need holes for the 9-pin socket and the octal socket, and I'll just mark these off and drill them in the same way. Now the 9-pin socket is going to take a 3/4 hole. I have that drill bit, but I don't actually have a drill bit big enough for the octal socket. So I'll do this off camera because it'll involve a little bit of grinding with a Dremel to finish up that hole. So here's the result of all my cutting. I've got my 9-pin socket mounted. The 9-pin socket is a top mount, and the 8-pin socket here is also mounted, but it's a bottom mount, so you can see the differences in those. Just happens to be what I had on hand. The 7-pin is also a bottom mount. Next we're going to move on to the PC board and at least trying to figure out where that's going to be located. I also have a rough idea for my diagram, but I did just kind of move the socket around a little bit, and the input jacks are slightly different than the way I drew them on paper. I still think it's going to fit in there just about where I wanted it to. I've got to figure out an attachment method, and I think I'm going to do something a little bit unconventional for that. And on top of that, I've got to figure out where my transformer is going to be mounted. I think the only place it makes sense is so that the wires come through in this location, and I think based on where my tubes will be, it's got to be something like that. Since this screw is going to be under my board, I've got a plan to mount this at the same time that I'm planning to mount that. I've also moved on to a few other things, and I'll show you some pictures of what I've got done here, but basically I figured out a mounting location for the output transformer. I've got a couple holes drilled to run wires through, and I went ahead and drilled for both the speaker jack and the ground that I've got set up here. This is the ground for the input connections. It's also the ground for the front controls. I wanted that separate from all of my power related grounds, which are all on the other side of the chassis. Inside, you'll see I've started making some marks in here. This is part of the mechanism I'm going to use to mount the control board itself. It's less of a mechanism than it is just me scuffing up the paint so I can stick some glue down to it. But basically, I've drilled some holes into the PCB, and I've placed some motherboard standoffs on the back here, and I'm going to stick this down with some hot glue. I've used that method before in some Bluetooth speaker builds, and it's actually worked out pretty well. And we can always go back to a more mechanical style of mounting if it doesn't. By the way, after you've had a chance to review some of the photos of the chassis that I took, I'll go ahead and mount the output transformer. Now, one thing you'll note, the reason I'm mounting the output transformer now is because one of the screws comes out under the control board, and that was one of the things I was worried about, but ultimately I decided that was the best placement for this. It does mean if I have to service the transformer in the future, I'll probably end up having to take out the board, but these motherboard standoffs are actually removable. You just squeeze them together and then pull them out. The wires from the output transformer run through a rubber grommet that I've got here. I used smaller grommets, one on each side, rather than one big grommet like the original Champ probably would have had. I did that really because that's the only size grommet that I had. But to be honest, it does make it look a little bit cleaner. So now that that's out of the way, I think I'm going to start wiring in some of the pieces of the chassis here that will be easier to get to without the PCB in place. So things like the chassis grounds for this wiring here on the pots, some of the wiring and resistors on the input jacks themselves, probably a little bit of the power transformer and power section over here. Then we'll move on to adding some components to the board itself and dropping that in place. So I'll show you a little bit of sped up video from when I started wiring this thing. Obviously I mounted the power transformer first, and then I just began soldering in some of the connections, mostly grounds, but I did wire in some of the front controls, and I completed the power section. I'll show you a photo of where things stand right now, and then I think we'll wrap up this episode with a quick look at how the amp is functioning at this point. It's not really much of an amp right now, it's really just a power supply, but I have everything wired in, including the rectifier tube in place. So I just want to test out some of the voltages and make sure everything's working. Now you're probably wondering what this thing is, and if you haven't seen any of the YouTube videos, not on my channel, but on other channels like Uncle Doug is a great channel to look at for amplifier stuff. But anyway, this is a power limiting device. It basically runs the amp in series through a light bulb, a high wattage light bulb, and if there were any shorts in the amplifier, it would illuminate this light bulb and take the load off of the amplifier. So it basically acts as a way to prevent any massive disastrous current flows through this thing if I happen to have a short. I've got a multimeter hooked up. I've got a connection on the ground of my amplifier chassis, and let's just plug it in and see what happens. Alright, so when I flip the power switch, obviously I get a pilot light, and that's a good thing, so it means my 6.3 volt winding is probably working okay. We're going to test that out though. Alright, so with my voltmeter on AC, let's try out one of the pilot light connections. And you see it's showing about 3.2 volts, which is just about right for my 6.3 volt winding. I'm going to test that here at the rectifier socket as well. 3.3 on one side, 3.2 on the other. So I've got about 6.5 volts coming through there right now, which is well within spec, especially after I add a couple more tubes. Now what I'm really curious about is what is the output or power supply of my amplifier section. So on one side of that connection, it is 330 volts. And same thing on the other side. So it's performed the same in testing right now as it did in my bench testing earlier. Just for fun, let's switch over to DC and see what's coming out of the rectifier tube. And if you don't know what a rectifier tube does, it basically acts kind of like a set of diodes. That's an interesting phenomenon, and you can look a lot more on those channels that I talked about. Again, Uncle Doug is a great channel to look at for amplifier builds, and I'm not going to recreate his content. But let's check out that DC supply here. Alright, looks like right now we're sitting at about 298 volts. So I think that's promising. It might actually go up slightly once I add my first filter capacitor, but I'm not going for a high wattage amp here, and I think that's well within spec to run the tube. By the way, just a note of safety, I know I talked about the power limiter already. One other thing is if you're ever working inside the chassis of an amplifier, you want to work one hand at a time, and that's part of the reason why I've got a clip to my ground so I'm not holding my ground with my other hand while I'm working in the chassis with this hand and the probe. But anyway, even if I've said it on other videos, I'll say it again, you don't want to have two hands in a chassis because current through two hands is passing through your heart. If you ever need a really easy way to remember this, put one of your hands in your pocket while you're working on the amplifier, and then you actually can't do the wrong thing. Okay, I can tell we're running a little bit long on this episode, so we're going to save the board wiring for the next one, so look forward to that. Be sure to subscribe and hit that notification bell if you want to make sure you're notified when that next episode comes out. Thanks again for all the likes and the comments. I appreciate everything you guys do, whether it's visiting my Amazon links in the description or joining my Hacks Guitar Hobby group on Facebook or subscribing or any of the other things you do to support the channel. So thanks a lot, and I'll see you next time.